Hello, I'm Bob Watchorn. I've been a geologist since 1972. Worked on the Golden Mile for WMC KLV from 73 to 76. I work mainly in the Chaffers Shaft end of the Golden Mile, and thus I know these lodes and geology well, which is why the purpose of this talk is to demonstrate that the EagleEye system produces valid geology of the Chaffers Shaft area in the Kalgoorlie Superpit from Australia-wide magnification of 9,000 times. The method by which I'll be doing this, I'll be proceeding through the convoluted method by which I achieve this impossibility so that the EagleEye methodology is shown and explained. I've included a template of the procedure so that even the least computer-savvy geoscientists can do this impossibility, as I've been told that it is, themselves on their own computer. First of all, what is EagleEye? EagleEye is really the enhancement of fuzzy images that don't show any structure, like the image there. Fantastic image, but doesn't show any structure. EagleEye has been developed by myself over the last 25 years in various guises, and I use the artistic effects buttons on PowerPoint to enable structure to be pulled out of non-structural images through the application of this powerful Microsoft pattern recognition and enhancement software. I consider EagleEye as the MRI of geoscience image interrogation systems. In other words, from that plan, I can get, that's 500 kilometres, I can get down to 100 metres and get good resolution with the lodes on the Golden Mile. I'd like to know if anybody else has got a system that does that. In order that you can follow at home on your own computers what I've done, this template shows the 8 enlargements that I've done from the Australia-wide magnetics and the 34 iterations required to complete the transformation. And this template ensures reproducible results by users of the EagleEye system. Many people have tried to use it, very few have come anywhere near even getting the first lot of images, so it must be hard. It's actually quite simple, just like tennis is simple, but you'll never become a Wimbledon champion without hours and hours and hours and days and years of practice. So just to recap, we go from Kalgoorlie, we go from Australia to a little section in Kalgoorlie down to that one. This is the original image. Just to make things difficult, that image is only 216 kilobyte. When I told geophysicists, they said, you absolutely can't get detailed anything off an image that's 216 kilobytes. Well, I'll just show you how you do it. So pattern recognition of that same image, you fuzz everything and you make it darker to cut down your regional gradients, and to darkening it brings in structures that you otherwise wouldn't see. More pattern recognition. Pattern recognition in Microsoft actually brings up a, erratics, I guess you would call it, on that northeast trend, but I've actually figured out a system whereby I can actually get rid of them. Wet look is actually sun angle, it's draping, so effectively you can see the highs and the lows and the valleys better. And then go back to pattern recognition to actually start to bring in the structures, which you can start to see them now cement, horizontal derivative with a sun angle. You can actually start to see the structures appearing now. Big ones running across here, one running up there. And back to pattern recognition, which actually sharpens up the structures. So you can now see these much more clearly. The ones running down through the eastern Yilgarn. And pattern recognition again. Pattern recognition software is just fantastic for starting to show up structures, which is actually what patterns are, I guess. You can get a geophysicist to explain it for you. Steve Mudge explained it to me years and years and years ago, and this is what I actually use, which was something that he'd started. Now you can start to see lots of structures. West-northwest is all over the country. Shark Bay, west-northwest. Got the north-south structures. But this geology is still fairly coarse, and I didn't think that I'd be able to pull up the Kalgoorlie area from that. So I went back to the cutting out a slice from Western Australia to get a bigger starting set. So this is what I started from, to just the West Australian magnetic, same data set, but just enlarged. Still, the original image is only 216 kilobytes. In fact, probably only a third of that, because West Australia is only a third of Australia. The ore body, or the mines on this image, you can see structures running through. And the big one up there, not particularly obvious, very fuzzy. So using pattern recognition software again, I've started to make the structures more clear. Pattern recognition again. So the pattern recognition is called pencil grayscale, and this is how much you actually use it. The 6 is the thickness that you use, so you can have really thick structures or thin structures. And so that's sharpness, brightness, and contrast. And with every image, you've got these 5 variations that you can do. So permutations and combinations actually add up to a great heap by the time you're finished. That's why it's so difficult to learn it. And now wet look, which is effectively highlights the highs in the magnetics and highlights the valleys. So very, very good for your broad structure, but not very good for the fine detailed structures. Mines now are starting to make a bit of sense. You can see these mines, the Q through to Plutonic, are all on this great big structure that runs through. Here's a little bit of counterintuitive stuff that I use, which actually is the secret to getting the fine detailed structures. And of course I came across it by accident as I was fiddling around on the computer, just seeing what all the buttons did. And effectively, it's a button called glow edges. And I've been told, and I've seen that it's an upward edge continuation, and also domains the areas, which in layman's terms was the old worming program. And I've used it plenty of times in other things. So when you, just in one stroke, you go back to pattern recognition, use those 5 variations, and you immediately bring out the fine detail structure. You wouldn't get anywhere with any of this unless you use these 2 steps. So you can see you can see lots and lots of fine detail structures now. So the comparison between using the Australia-wide, and I went through exactly the same steps on both. The Australia-wide one shows the major structures very well, but the lacks detail. And in the right-hand side one, much greater detail of local structures, which is actually what I want if you want to get down to Kalgoorlie and Norseman. You can't do it on this one. It's most important to note that the major structures are seen on both plans, so there's nothing that's actually really that different between the two. And so from that we go down to the East Yilgarn, which is, in this case, is from about Leonora down to Norseman. This plan here. And if you note the strong structures running in this direction, they occupy an area something like that, and up here there's none. That's actually the where the main gold-bearing areas in the Eastern Yilgarn are. So there's a clue as to how accurate these things are. We'll now go down to Plan D, which is the Kalgoorlie to Norseman section. Just a cutout from the previous plan. You can see the linear structures a lot better now than what you could on the large one. In this particular plan, you can see that both Kalgoorlie and Norseman, but not Kambalda, lie on the intersection of numerous east-northeast, west-northwest and north-south structures. And Norseman does as well. Generally speaking, the major mining areas, or the ones with the big gold in one concentrated area, are on the darker, much more tectonically active areas. And I've proved in numerous places around the world that you get an increase in magnetism or magnetic minerals with increased tectonism. So using pattern recognition on that again to bring out the structures. Then I use the wet look again to bring, now this brings out different structures. So it's actually bringing out the, actually obscures the minus, or the what would be very late structures, and brings out the earlier, more magnetic minerals. So from now we're going to go down to E, which is specifically the Kalgoorlie area. So this shows the enlargement of the Kalgoorlie area. So Kalgoorlie sits there, and the Superpit sits between there and the higher magnetics here. Nothing too special about that, and most people wouldn't get much from it. But even so, that's still like totally far in advance of what pretty much anyone else would get from that original Australian plan. So you use pattern recognition on that image, and you're starting to see, they don't look particularly convincing, I guess, but you're starting to see patterns there. Our aim is to pull out structures, linear structures, circular structures, any structures. So using pattern recognition, plus those 5 other buttons to highlight the structures. Now we've put the wet look on to increase the differentiation between the higher magnetics and the lower magnetics. And then cement, which is like a horizontal derivative, so it flattens everything out, takes out your magnetic topography, and also gives a bit of a sun angle to highlight the high areas that are still there. now we're starting to see some structures starting to come through, north-south ones. Anybody who knows Kalgoorlie will be starting to recognise this lot here. Then we use the wet look again to highlight other structures. Now we're starting to see nor-northeast structures. And pattern recognition again. Now we're starting to see relatively clear structures that actually are in the same line as the Kalgoorlie lodes. And anyone who knows anything about the Kalgoorlie Kambalda geology will recognise that as the Boulder-Lefroy fault zone, which is exactly what it is. And it's not like it's drawn on any maps. But I would vouch for this over any mapping that you do in the Eastern Goldfields. So back to pattern recognition again, and it shows where the Superpit is. It's right there. Superpit's a bit bigger than that now, but not much bigger. Same at the north end and bigger at the south end. All right, so geology of the Superpit. This should be quite revealing. So this is the area we're looking at. You've got your big major faults running through the south end of just off the south end of the Superpit. And you've got big major faults on the two angles sitting in there. You've got Boulder-Lefroy fault zone running up here, all faulted. You've got Boulder-Lefroy fault zone running up there, all faulted, but with the opposite symmetry to what they've shown on that plan. I won't go into the lodes there, do that better later. So we'll now go down into the Superpit. So following the Australia-wide structures that we saw in the first lot, you've got strong structures showing through here, which is the Boulder-Lefroy. You've got strong north-south structures, which is the Adelaide fault system. You've got east-northeast structures and west-northwest structures, quite clearly seen. And they are all known to be where they are on the ground in Kalgoorlie. And so it's like a fractal system. You go from the Australia right down as far as you can get, and you're still getting the same structures. That's further pattern recognition. This one's the cement one, which is the flattening of everything, and it highlights now the different structures. In Kalgoorlie, this is from the 1995 OSM monograph. They're the lodes. So your main lodes run up in that direction, contour lodes run in that direction, and the cross lodes run across in that direction. All of those elements can be seen here. So that's the main lode there, cross lodes there, and the contour lode sitting there. We'll see now whether they actually fit with where the actual main lodes are in the Superpit itself. Well, they do, but can't see it that well on here. The actual major nodes, things that this system brings out that no other system's brought out as far as I can see. One of them is the major northeast trending broad fault zone that just appears across the north of the Superpit up in the Croesus area, and that's the termination of the lodes up there. So we'll go down closer into the Superpit now. So we should be starting to get the hang of this now. So this is on the right-hand side is actually the mapped lodes. And you can see the cross the biggest cross-lode system set up in the Perseverance, South Cal, North Cal area in this very complex area, which almost looks like a plug. And they're sitting across like this. That's what they actually are like. B-lode, I think that one is. The main lodes sitting up in this direction, that's exactly the direction they sit. And the contour lodes sit in there, which is exactly the direction they sit. So it's, well, I would say better than good correlation of the map faults and lodes in the eagle-eye magnetics. I mean, they're exactly where they should be, not just an approximation. And the faults, you can see these major faults running through. That's the Adelaide fault. That's a Hannon Star fault running through. So I actually worked in this area. So I've been on both sides of that fault, those faults, looking for ore. And I tell you, they're a very sharp cut-off. Another thing that came out of this was the what I think is the actual plumbing system for the Kalgoorlie ore system. When I was looking at it and fuzzed my eyes a little bit, I could see these two large ovoids, I guess like a donut squashed a little bit, with various littler ovoids in the middle, and then another one there. The Superpit sits right over them, or at least over most of them. So the thought was that these are excellent exploration targets. The Golden Mile has had at least 3 or 4 pulses of mineralisation, ranging from about 2635 for the first sulphide mineralisation, maybe a bit earlier, through to 2625 for, or a bit later for the telluride mineralisation, and 2600 or a bit later, a bit earlier than that for Mount Charlotte. So we know that this area has had at least 3 pulses of mineralisation. The interesting thing is that where the two cross there is actually where you've got the absolute best lot of mineralisation. I think that, and that's the tellurides. That's your main tellurides in the pit sit in there, the best grades. Sort of further evidence that these pipe-like looking things are actually the mineralisation plumbing system. And I've proved on every continent that the gold mines, if you plot in seismic tomography, you just keep plotting them down, that the gold mines sit over a plumbing system that's subvertical. So in other words, you possibly wouldn't be looking for another Kalgoorlie Golden Mile like Western Mining did back in the 60s off to the south. You'd be drilling straight down under this. So exploration area, well, I think the enlarged pit's got this covered, and I'm sure they're not putting it out for nothing, because effectively there's really nothing out there on the old lode system, but they've obviously got low-grade mineralisation out here, which supports my theory that these are the, this is the plumbing system. But the one of more interest is this one here, which unfortunately is right under the soon-to-be 37 million tonne a year plant, and possibly a bit of the slime dumps. But if it's anything like what I think it is, it'll be, and it's in the Paringa basalt in the footwall, as is a lot of the lodes up in here, that at possibly 0.8 to 1 grams, which you can mine with a 37 million tonne a year plant. Probably you could leave the plant sitting there, but you would go for this stuff. So all you northern mining people, you just take note that there's your next exploration target. And so we're going to now enlarge, coming into the southern part of the pit. So we've done a cutout of the southern part, which is this one here, minus the lodes, and effectively use pattern recognition on this to once again darken it and get more of the structure in. And we've used pattern recognition again and lightened it to firm up the structures. So you increase the contrast and increase the sharpness. And then this, which looks like a dog's breakfast, actually is a vital stage of actually getting good sharp lodes. So you use pattern recognition again. And with the various buttons, you can actually get the main system of lodes looking a lot sharper. That's not much good to anyone, but if you then give it a wet look, you start to pick out the high magnetic areas. Well, as I've said, the high magnetic areas aren't necessarily exactly what you're after. Although in Kalgoorlie, certainly the lodes have got lots and lots of sulphide in them. And so you use your cement horizontal derivative, which once again looks a little bit like a bowl of spaghetti, but it's just an interim step to try and pick out the finer detail, sharp lodes. All of this stuff actually takes ages to sit down and figure it out. Many mistakes. And all extremely exciting to adventurous people like myself. So then you use the wet look on that, which highlights, now we're starting to highlight what are actually the lodes. And you'll see that later on, main lodes, contour lodes, cross lodes. One thing that I've noticed all the way through, and I've pointed it out, is that this was the central area that I said where the two ovoids overlap, and that's that area there, and that's the most prolific. That's what started the Superpit. I was there when we actually did the reserves and resources for this part of it. 30 million tonne at 3 grams all around Perseverance down to the 12 level. They were only interested in underground mining at that point. Been there. So we now go down to the south end Chaffers area, which was my home back then, although back then I actually was a bit of a roaming geologist, and if anyone had something they wanted to show me, I went from one end of the Golden Mile and up to Chaffers and helped them with their mapping and stuff. Completed this final eagle-eye enlargement exercise on the Chaffers area where I worked from 73 to 76, which I reiterate I knew intimately, so I know if these results are valid or not. And I'd have a guess that there's very few people that can say that. So this is back to pattern recognition on the southern part, south end of the Golden Mile, Chaffers area. The sea is Chaffers Shaft. This is from the 1955 AusIMM monograph, of which I've got copies of all of them, very useful reference tools. And that's the pattern of lodes then, and actual fact, the 1995, they'd only actually extended a few of them a little bit. So while they mined them up and down, this is at 200 metres depth, the old 12 level. And you can see that the contour lodes are following this pattern, running around into the main lode pattern. So number 4 lode, which before the Superpit had mined somewhere near 5 million ounces by itself, follows this north-northwest trend. You can see down here how both the lodes and everything splay out, very similar to what's shown on mine. So this is the wet look of that same area. And then I did a cutout look which shows the lodes, or shows the areas more domained. So the Morrison's lodes, which sit in here, sit through this anastomosing sort of area, and they're anastomosing. 4 lodes sits right on that one. Chaffers Cross sits on this one. And so that's how they look. Now, remembering that this has been got from the Australia-wide 216 kilobyte plan of Australia-wide magnetics. Now, I'll dare anybody to get something like that even with a local high-resolution magnetics. I'll be very interested to see if anyone can, mainly due to cultural influences. So takeaways, EagleEye does work. Geology was obtained for the Chaffers Shaft area. EagleEye can be used on any area in Australia or globally. There is now a minimal requirement for local geophysical surveys when you actually can't get any better than that anyway, so what's the point with a lot of it? I remind you, you can use this on anything, gravity, seismic, anything. If you want to get a 3D model of Kalgoorlie, absolutely beautiful one, do 3D inversion plans and cross-sections of TEM, magnetics, gravity, anything, and you'll get a true 3D project model. The MRI EagleEye system will catalyse and telescope our exploration procedures. And my prediction is that EagleEye type systems will be the new standard for geoscience software in the future. The objective of this talk is to demonstrate that the EagleEye system produces valid, detailed structural geology of the Norseman North Royal open pit from Geoscience Australia-wide magnetics, magnification of 5,000 times. The EagleEye system has been developed over the last 25 years. I use the artistic effects buttons on PowerPoint to enable structure to be pulled out of non-structural images through the application of the powerful Microsoft pattern recognition enhancement software. I consider that EagleEye is the MRI of geoscience image interrogation systems currently. So we go from Australia-wide magnetics down to the North Royal, which is a huge leap. So the original image is only 216 kilobytes, and we start off here, we take a slice out of the original, and then in a few increments go down to Norseman. That's the first one. That's the eastern Yilgarn from north of Menzies, just south of Leonora down to Norseman. It's the original image that we start with. So we use a wet look, which highlights the high magnetic areas. And then we use cement, which actually reduces the high magnetic areas and brings out more structure. Then we went from there, we're down to the eastern Yilgarn, from Ora Banda now down to Norseman. So we've enlarged up and we've used pattern recognition on that, all from the same original image. We're now starting to see the mine starting to line up with structures. We're going to enlarge to the Norseman area now. We've used the wet look to re-establish the high magnetic areas, which you need to do once you actually want to enlarge. So that's the what I get for the geology, so to speak, of Norseman, and this is the same thing in the actual geology. If you overlay the two, they're like almost identical. So use pattern recognition now on the Norseman area. Starts to look a bit fuzzy, but I'm trying to get structure out of it rather than prettiness. Pattern recognition, going dark again to bring out structures, and I can start to see structures, particularly that northeast one. To a wet look to re-establish the high magnetic areas. Another wet look to actually get them in more detail. Now start to see things like the Jimbalana dike cutting across. Back to pattern recognition. Each of these little incremental steps brings you closer to actually seeing the structure. So now you can start to see the more minor structures starting to come in. This one is glow edges, which is a upward edge continuation, worming as it's called, and it domains out areas of similar magnetic intensity and gives them and the surrounding area a very sharp boundary. So it's a great thing for focusing and bringing out structure. Also, it's got the advantage of you can slide the button and you can make everything, you can take out your highs and lows in the colour. Another one with glow edges. So now you're starting to see what I'm looking for, which is the fine detailed structures of Norseman. And even at this scale, I can see that they're in the right direction at least. Back to pattern recognition to make them clearer. So we've gone from Australia-wide image to the pattern recognition image basically, and then to the worming image. And at each stage you actually get more geology and structure and stratigraphy. This is all stratigraphy mainly. And so at that stage I figured I'm going to compare mine to the best image that I could get from the Norseman mine. That's the magnetic survey that they did, and they compiled it from heaps and heaps of magnetic surveys. Now, I don't see that is any better than that in terms of the broad structure, and the stratigraphy shows up a lot better. Like that's showing that all of this, what is shown in the normal magnetics as bland looking nices, has actually got lots of stratigraphy in, which you know when you walk over it that it's just stratigraphy that's been niceified. So we now go down to the Norseman area. You can start to see lots and lots of structures here. Now these structures are fractal from effectively the Australian-wide image, the very first lot that I got, right down to the local scale. There we go down again to the Norseman area, and we've got start to enhance it again with glow edges, pattern recognition. Now we're starting to see what I know are the lode structures. Glow edges, sharpening the edges of the different units. Now we're going down to the north area of Norseman, the North Royal area, which is the area that I worked in from 78 to 80. So enlarge that up. There's the North Royal mine there. This is stratigraphy running around here, which I know is valid. And the other stratigraphy sits out here. That's an enlargement of the actual geology. So that point there is actually that point there. This one doesn't show up on the geology, but I know that is the high magnetic stratigraphy that runs past the North Royal. So we go from that scale down to the North Royal. Once again, I've used pattern recognition on that, which effectively we're now looking at that area here. It seems to fuzz it up a bit. And when we finally get down to North Royal, so we'll start with the open pit. So I mined this pit, I was in charge of it, got told off for not wearing safety boots, and the managers thought back in 1978 that thongs just weren't right for the pit. Not wearing a hard hat, how things have changed. This is the mapping from the pit. So the footwall lode's right on the footwall of the pit, and the hanger wall lode's right next to the shaft. You've got cross lodes sitting in here. When you go across to the actual geology, you've got your main North Royal fault zone, which sits in the hanging wall. It's sitting up in here. And these two areas here in the pit were two domal areas, very high grade. And that's actually what my translation across, so it's actually quite accurate. So in this case, we've gone right down to way down there, 100 metres, that's 100 metres from 500 kilometres. And the conclusion, the EagleEye system is a paradigm change in our exploration systems and procedures. And my prediction is that EagleEye systems will become the new standard for geoscience software. I want to demonstrate that the EagleEye system produces valid, detailed structural and body geology of the Norseman Mainfield area from geoscience, Australia-wide magnetics. The Mainfield reefs have got lots of problems for magnetics, and as far as I know, nobody's ever been able to crack it. The reefs are thin, sulfide poor, and discontinuous. We couldn't even follow them underground, and they will be difficult to pick out. I started off with the 216 kilobyte Australia Geoscience Australia Magnetics plan, and we'll be starting off with this image and going down and down until we finally get to the Mainfield Norseman images. So this particular image is the fourth enlargement to Kalgoorlie to Norseman area. It's a wet look, gives prominence to the high magnetics, but not very good for detailed structure. And fifth enlargement, we go down to the Norseman area. Once again, I've given it a wet look so that it brings out the regional structure, which is initially what we're after. And this plan is actually a structural, much more structural geology in it. And you can see the structures coming through. I've used various imaging techniques to get down to this level. One thing that I noticed as I was doing it that doesn't come out in most things, at Norseman, there's this hugely circular area of very, very broken up stratigraphy, almost like a breccia. And my thesis is that, and I've proved it on many continents, that when you follow these, if you put a seismic tomography plan from 70 kilometres but down beneath Norseman, you'll find that that's the area straight under Norseman is the most tectonically active. Go down to 150 kilometres, you'll find exactly the same my contention is that a lot of this mineralisation has come up from the core up through pipes. If you want to more on that, you can go to my website, GeoTricks, where I've seen this in every continent. So that being the case, if you want to explore for more ore in Norseman, under the Mararoa, go straight down under the Mararoa. So we'll now come down to the Norseman area, in fact the area south of the Jimbalana Dyke, which is this major structure across here, or it's a Proterozoic dyke. 2.49 gigaatoms. That doesn't look particularly smart. It's the 6th enlargement to the Norseman Mainfield area. I thought initially, oh, I've made too much of a jump here, I might have to go back. But I had a bit of a fiddle with it. Pattern recognition, darken it up to bring in structure and lower your contrast between high and low signal. And then pattern recognition again, where you reverse the thing, but you use a fairly tight search distance for the structures, and that brings out your structures a lot more. Once again, exactly the same thing. Again, the same thing, but I've used the wet look, which I've now highlighted the high magnetic areas. As I've said, these areas are generally speaking where you find the best gold. You very rarely find gold in these areas, which is extremely useful if you're exploring in Northern. You're not going to go looking all the way up and down here or out in here, but you would be looking in here or around here. And then I did another iteration of the wet look to highlight them more. You can start to see quite a lot of texture and different structures running through. So I overlaid the lodes on them. The main thing to notice here is the faults don't show up that well, but where I know they're strong, they're actually following north-northwest trends. The main lodes sit down through there. Once again, they don't show up particularly well. That's the crown lode on a slightly different direction, Mararoa and Norseman lodes. I thought, well, they're very thin. Wouldn't expect to be able to really see them. One thing that is interesting, though, is that the areas where they outcrop and the very highest grade areas are all in the black, or on the junction of black areas and the white areas. You just don't find ore out in these areas. I mean, that is tremendously important targeting information. And I can do this with any field, gold field or copper field on Earth, so it's not just restricted to be able to go to Norseman. The most interesting thing to me is the cross reefs. Nearly always are sitting on northeast trending, or the flexure of various high tectonic areas. These are the ones that really you make a killing out of. OK sits on that one. Valkyrie sits there. Mildura sits there. They just correlate so beautifully. However, I wasn't satisfied, so I used glow edges again, the worming effect, to try and get the more detailed structure. That's the good thing about this type of stuff. So enthralling that I lay last night thinking about it and said, not happy with that. So I got up at 5 o'clock this morning and produced these few slides. So pattern recognition, you've knocked out that really high magnetics and you're separating it out into the actual components of it. You see very strong northeast trending running through here. And you can start to see a north-south trend running through. As I thought, it was quite discontinuous. Does it line up with the lodes? Because if that lines up with the lodes, then like that is a real achievement, because you really can't find magnetics. Even the best magnetics in Norseman don't give you that. Does that line up with the lode? Gave it another iteration to try and make them stand out better. Partially successful. So I put the lodes on, and while it doesn't line up with the lodes exactly, they're in exactly the same direction. Maybe I got the lodes in the wrong spot. But up here, they do line up with the lodes. This one here lines up with the much, much weaker Norseman reef. This one over here lines up with the St. Patrick Reef, no, Mount Barker Reef. And these now start to see the things. These are very late, these cross reefs. You can now start to see the trends on them that they follow. So you see them coming through. And I'm sure if I had more time, I could make it a lot better. So we go once again from Australia down to Norseman, North Royal, down to the Mainfield in Norseman. So you could do that for anything. You could do that for Victorian goldfields. You could do it for Olympic Dam. You could do it for Broken Hill, Mount Isa. You could do it for anything. It's not specifically for gold or anything. So the takeaways from this talk is EagleEye works. Geology is obtained for Norseman, North Royal and Mainfield. EagleEye can be used in any area in Australia or globally. Minimal requirement for geophysical surveys with huge reductions in cost for exploration programs. Like, I would guess trillions of dollars if you added up all the amount of stuff, and they still can't get this like has been got here. 3D inversion plans and cross-sections enables the construction of true 3D project models, none of this computer-generated leapfrog stuff. And this will be invaluable for exploration ranking. Conclusion, the MRI EagleEye system will catalyse and telescope our exploration procedures, and my prediction is that EagleEye type systems will become the new standard for geoscience software. Thank you for listening to this talk.